On my screen, we have the Softjaw Mill project. This is where we left off last class. Every time I open up an existing session of Mastercam, just to get an idea where I'm at, I'm going to run the existing toolpaths inside of Verify. So to do that, I'll select the first operation toolpath group. I'll select Verify. Now, before you do that, make sure there's green checks next to everything. I'll run Verify. Takes a moment to open up. And once it opens up, we'll make sure that the stop condition collision is turned on. And it's looking a little odd to me. Hold on one second. I think I'm frozen up. There we go. All right, so Verify has opened up. Make sure stop condition collision is turned on. It increase the precision a little bit. Just be aware that this can slow your computer down. I'll select play. Okay, so it appears as if we've got as far as engraving our initials in the part. What we'll need to do now, just at a quick glance, we'll need to break the sharp edges that we created with the toolpaths that we've programmed. And we're also going to create a chamfer on this edge, the edge that's between the drilled hole and the bottom of the counter bore. But before we do that, let's reference the project page and see what we're instructed to do. So under creating toolpaths, first operation, that's what we're currently working with, says use the helix bore toolpath to create the 0.813 counter bores in the part. We've already done that. Step 9, use a counter bore toolpath to create the engraved initials. We did that. Step 10, use a contour 2D chamfer toolpath to create a 0.03 by 45 degree chamfer on the edge of the hole in the bottom of the counter bore. Okay, so that's what I was just talking about. I'll go back into Mastercam. I still have Verify opened up, so I'll close out of Verify. We're going to create that chamfer. Now, this isn't called out on the blueprint. I'm just giving you instructions to do this. We're going to create a 30 thou by 45 degree chamfer on this edge and on this edge. And we're going to use let's check the tool list. We're instructed to use a 1/4 inch chamfer mill, 90 degree included angle, 2 flute. And they also identify the tool holder that we're going to use. And it's going to have a 1 inch tool projection. So I'll go back to Mastercam. I've got my insertion arrow at the very end of the toolpath group. From the toolpaths tab in the 2D section, I'll select contour. That's going to bring up the chaining dialog box. Now mine's currently set to wireframe. I'm going to change it over to C-plane. And then for the selection method, I'll use chain. So the mode is wireframe, C-plane is selected, and selection method is set to chain. I'm going to select this circle and this circle. I'm selecting wireframe geometry. And I will select it right around the 1 to 2 o'clock position, left click. Now, when we use a contour toolpath on what's referred to as an internal feature, a pocket or a hole, we want the chain to go in a counterclockwise direction. Mine's currently going in a clockwise direction. To change that, I'll use this icon here, reverse. And then I'll come over here and I'll select this circle at around the 8 o'clock position. And then because of the way I selected it, it is going in a counterclockwise direction. So I need both chains to go in a counterclockwise direction. Once I select the chains, I'll select OK. and that'll bring up the parameters for this toolpath. We'll start by going to the tool list. So select tool. We're going to add that 1/4 inch chamfer mill to the tool list. So I'll select the select library tool icon.
I'm sorry, Professor. I'm a little screwed up on the selection
Okay.
step. I'm not sure if I'm on the right level.
You're not sure if you're on the right level. It
What?
doesn't, the level doesn't matter. Do you have the, but what does matter is that the wireframe level, the wireframe from solid level is visible. Can you share your screen with me?
That was it. I had the wireframe from solid level invisible. That's
Yeah,
what
make it visible, and then you will be able to select those circles.
I got it now. Thank
All right, perfect. Okay, so select those 2 chains, and then once you select OK, it's going to bring you to the toolpath dialog box, and then go to the tool list. We're going to add that 1/4 inch chamfer mill to our tool list. So I'll select library tool. And my filter is still active from the previous contour toolpath where we created the initials. So I'll select the filter icon. And this time I'll deselect all tool types. I'll select chamfer mill. Now the chamfer mill upper right corner looks a lot like the center drill, or spot drill, I should say. So select the chamfer mill. For the tool diameter, I'll set it to ignore. I believe there's maybe 6 or 7 chamfer mills coming out of this library. So chamfer mill, ignore, it will show us everything that's in the library. I'll select OK. There's actually 4. In my case, tool 318, it's the 1/4 inch chamfer mill. I'll double click on it. And it's added to my tool list as tool number 8. We'll need to modify the default settings for this tool. Right click on the tool, select edit tool. It's taking a moment. Hopefully it's not crashing. Well, that's not good. There we go. Got lucky. Okay, so depending on the chamfer mill that you have, you're going to want to match the tip diameter to whatever the tool manufacturer that you're using has. The ones that I have at work, if you look at a quick glance, they look like they come to a sharp point. But in reality, if you look at them with a magnifying glass or an optical comparator, there's around a 10,000ths flat at the very bottom. So let's set the tip diameter in this particular case to 0.01. At a quick glance, doesn't look like there's anything there, but if you zoom in, you can see that there's a small diameter at the tip. That'll be all the changes that we make to this page. I set the tip diameter 0.01. From here, I'll select next. According to the tool list in Canvas, this is a 2 flute. So let's set the number of flutes to 2. If I calculate the RPM, you can see that it maxes out at 10,000 RPM. That's the machine's limits, or the high limit for the machine. From here, I'll select show more options. I'll select coolant, and then I'll set the flood coolant to on, and then I'll select OK. And that'll pretty much complete everything I need to change on this page. So from here, I'll select finish. Now this spindle speed is not matching the one that we just calculated. I'll have to research that, but this will work. For the FPT, set this equal to 1% of the tool diameter. The decimal equivalent is 0.25. So 0.25 times 0.01 It's calculating my feed rate at 22.92. Let's set the plunge rate to half the calculated feed rate. So 22.92, divide that by 2. I've got rapid retract selected. And in the comment field, I'll borrow the tool name, paste it down here. We'll say machine, all caps, 0.03 chamfer. Let me double check the instructions on that just to get the values correct. Yeah, so 0.03, that matches. So that'll complete all of the changes that I need to make to this page. From here, I'll go to the holder. This will be a Cat 40 ER32, so I'll open up the Cat 40 tool holder library. I'll select Open Library. CT40 inch, open it up. And according to the tool list, we're instructed to use C4C3-0032. So C4C3-0032. And then we're also instructed to set the tool projection to 1 inch. And that'll complete all of the changes that we need to make on this page. From here, go to cut parameters. Compensation type. Let's set it to left. I'm sorry, let's set it to where. Compensation direction would be left. So type is set to where. Contour type. Expand this menu, set it to 2D chamfer. And then for the chamfer width, set this to 0.03. And then for the bottom offset, set this to 0.025. Now you got to be careful here. It's not 0.25, it's 0.025. So chamfer width is 0.03. Bottom offset is 0.025. I've got stock leave on wall set to 0. I have stock leave on floor set to 0. I'm not using depth cuts. Lead in, lead out. Let's turn this back on. And I've got mine set to the default values. I got 25% for the line in, 25% for the radius, and I have the same values carried over to the exit. These are my default settings. Breakthrough. Make sure that breakthrough is turned off. Multi-passes. We could use multi-passes. I'm not too concerned about the surface finish on this. This is just clearance for the underside of a socket head cap screw. So I'm just going to leave multi-passes off. I'll go to linking parameters. Now, most of these values are carrying over from the previous toolpath or the previous contour toolpath. I'm going to turn off retract, feed plane set to 0.1 incremental. Top of stock. I'm going to set the top of stock I'll select that. But actually what I'm going to do is I'm going to set it to 0 incremental. And then I'm going to set the depth to 0 incremental. And what happens is when we set both of these to 0 incremental, it uses the Z position of the geometry that's driving the toolpath to determine where it's going to position the tool in Z. And with that said, I'm actually going to activate retract again. We're inside of a pocket, and I want to make sure that I'm well clear of the pocket before I move over in the X and Y axis. So I've got retract set to absolute. Select the retract icon. Select the top of the part. And then add 0.25. And I'll do that again. So for the retract, set it to absolute. Select the retract icon. And then pick select something that represents the top of the part. And then that 1.48, select next to it, and then type in plus 0.25, hit enter. Remember, this is an absolute value. It's relative to the current coordinate system. So when it retracts and repositions itself from one hole to the next, it's going to be at 1.75 inches relative to the current coordinate system. So here, from here, we're good. Let's select OK. I'm looking at the toolpath. We start here. We descend into the pocket. We have one pass around the bottom edge or this edge of the bottom of the counter bore. It retracts, it repositions itself to the second counter bore. It descends and then it machines the chamfer. So I don't see anything, I don't see any issues with this toolpath. The lead in and the lead out, you want to make sure that's happening where there's no material, so it's on the inside of the hole. Remember, we've already drilled this out. And the same thing's happening over here. If you see the lead in and lead out, these this arc move, if it's inside material, the chain is going in the wrong direction. You'll have to flip a few things. So from here, if I select just that toolpath, I select backplot. I can see the tool. I'll select play. I can speed it up a little bit. I think that looks good. I don't see the tool moving to the material. So from here, I'll exit out of backplot. I can toggle up the display of this toolpath. I'll select this icon here, toggle display. Looking at it from an isometric view, and I'll fit the screen. Now from here, make sure you save your work. We're going to run it and verify. I always recommend saving your work prior to going into verify. Select the entire first operation toolpath group and then run verify. Stop condition collision is still turned on. I'm going to activate the color loop. That will assign different colors to the surfaces machined by different toolpaths. If I go to the verify tab, so I'm inside of verify, select the verify tab, and then select on the color loop icon. From here, I'll select play. Now, if I zoom in, I'll tumble my view, and if I zoom into one of the counterbore holes, you can see that 30 thou by 45 degree chamfer at the bottom of the counterbore. And that's what I want. So that looks good. I don't have any collisions. The next thing we'll do is we're going to use a similar toolpath to break the sharp edges on the outer edges of the part and then on the inside edges of the counterbores. So this looks good. I'll exit out of verify and I'll save my work again. So now that we've created the 30 thou chamfer at the bottom of the counterbore holes, let's create a stock model that reflects everything that we've done up to this point. So once again, make sure that the insertion arrow is at the very end of your toolpath group. You're going to go to the toolpaths tab. In the stock section, select stock model. And let's start by giving it a name. We'll call this 0.03 chamfers. For the initial stock shape, I'm using a stock model. Let's create the stock model, or the last stock model that we did prior to this toolpath. It'll be the engraved initials. From here, go to the source operations, and I'm going to select the contour toolpath that we just created. This is the 2D chamfer toolpath. I'll select OK. Now, as the stock model starts to get closer and closer to the solid model or the finished model of the part, it becomes difficult to see what's actually going on with the stock model. And this one's taking a moment. If I zoom in, I can see I can almost see the chamfer, but just to be on the safe side, I'll go to the levels manager. I'll make the solid model level invisible. And now if I zoom in, you can see the chamfer. I got the 30 thou chamfer on the edge. And this is what we're actually going to see at the machine after that chamfer mill machines those chamfers. So once you verify that the stock model is correct, I'll make the solid model level visible again. I'll make the stock model level invisible, or I'll toggle the display of the stock model off. I'll save my work. I'll go back to the project page. Let's see what we're instructed to do next. Step 10, or actually we're moving on to step 11. Use a contour 2D chamfer toolpath to break all sharp edges created by the first operation. So everything we did so far is considered the first operation. What I'm going to do is I'm going to copy the chamfer mill operation that we just created, and I'm going to make a few changes to it so that it works for all the sharp edges that we want to break. Back inside of Mastercam, left click on the contour 2D chamfer toolpath that we just created. Make sure that you only have a green check next to that toolpath. Once you have it selected, right click on it. From the flyout menu, select copy. And then left click next to, actually just right click next to the insertion arrow. And then from the flyout menu, select paste. Now it's real important that you only have the one selected, otherwise you're going to make a big mess for yourself. From here, expand it. Now yours might already be expanded, but I need to expand mine so I can see the geometry. The geometry that's currently associated with this toolpath is for the bottom of the counterbore chamfer. I'll select the geometry. And once you open up the chain manager, you'll see the chains that are currently in that list or on that list. I'll right click, rechain all. From the wireframe chaining dialog box, mode is set to wireframe, C plane is selected, selection method is set to chain. Let's start by selecting the outer edge right about here. I want the external feature. I want that chain to go in a clockwise direction. And then from here, I'm going to select this circle at around the 2 o'clock position. It's going the wrong way, so I'll flip it. And then I'll select this circle at around the 8 o'clock position. Once you have all three chains selected, select OK. And when the chain manager becomes visible again, you'll see the directions of the chains. The large arrow shows us the direction of the chain. The small arrow shows us which side of the chain the tool is going to be on. So for the external feature, we want the chain pointing outboard. And then for the two internal features, we want the small arrow pointing inboard. So mine are correct. From here, I'll select OK. Now we're not seeing anything because we're modifying an existing toolpath. Go to the parameters. So we already updated the geometry. Go to parameters. Go to linking parameters, going to cut parameters. Where it says chamfer width, let's reduce this. We're just breaking the sharp edge. We don't want to put a large chamfer on the edges that we have selected. So set this to 0.01. And that should do it. If I go to the linking parameters, you see how these are set to 0 incremental for both the top and the depth. Once again, it's going to reference the selected geometry that's driving the toolpath. Once we selected the new geometry, that hasn't really updated, but because of these settings, the new geometry will work just the way it is. It's going to reference the Z position of the newly selected geometry. From here, I'll select OK. I'll need to regenerate this toolpath, so I'll select regenerate all dirty operations. In this case, that'll work. Once it regenerates with just that toolpath selected, run backplot. Once again, you want to make sure that the tool is on the correct side of the feature that's being machined. From here, I'll exit out of verify. I'll save my work. Looking at it from an isometric view, zooming out a little bit. I'm going to select the entire first operation toolpath group. Now, the one thing that we're going to do after we verify this or run these toolpaths and verify, we're going to save that machined model as an STL file. And that's going to become our stock for the verify of the second operation. So all toolpaths are selected. I'll select verify.
So when I go to hit backplot,
Yes.
it is bringing up like all the operations when I only have the number 18 selected.
Okay. So toggle off all display, toggle off this icon right here. And then select just that last toolpath. Got a green check next to just that one, right? Now, are you selecting this icon or are you selecting this icon? Because that is toggle display.
Yes.
That is backplot.
So I'm hitting the backplot on number 18, and I have the green check just next to 18.
Okay.
Okay. Now, I don't know why, but I didn't do anything, but it just fixed itself.
And it'll do that sometimes. So, but you're good?
Yes, it fixed itself now.
Oh, perfect. Okay, so I'm going to go back to, now it might not verify the way I expect it to because there we go. So I'm inside of verify. And let me back out just because I did change some things. I want to make sure I'm doing this correctly. So I've got the entire first operation toolpath group selected. I'll select verify. Stop condition collision is turned on. In this case, I'm going to increase the precision a little bit. Once again, just be careful. This will slow your computer down. I'll select play. Okay. And once it's done running and verify, I like to zoom in. And I'm just inspecting the machined model. So you can see I've got the larger chamfers at the bottom of the counter bore. I've got the 10,000 chamfer at the top of the counter bore. And then on the outer edge, if I zoom in, you can see another small chamfer. So this is going to complete the first operation. What I need to do is I need to save this machined model as an STL file. And then I'm going to use that as the model or as the stock for my second operation verify. So I ran the entire first operation and verify. Once it's done, go to verify. Far right side of your screen, you see save stock as STL. Select it and save it to the working folder. So I'm going to go back to the MACT fall 2020 or MACT 160 fall. This is the Softjaw Mill project. And in this folder, I'm going to call this first operation complete. I'll select save. Now this will sometimes take a moment, so be patient. It's going to create the STL file. And then once we have the STL file created, we can reference that or import it for the stock for the second operation verify. And I'll show you how to do that here in a moment. All right, so once it's done saving, you can exit verify. That completes everything we need to do for the first operation. If I go back to the project page, let's see here. It says we just completed step 11, step 12. Create the NC file using the post selected operations icon. And then create the STL file that reflects all the toolpaths from the first operation. This file can be used in verify for the second operation. So we jumped ahead to step 13, and I'll need to make that change. That's actually step 13. Let's backtrack and create the NC file. So I'm in Mastercam with just the first operation toolpath group selected. I can select G1. Now you guys can't do this because you have the home learning edition of the software. Once you get back on campus, you will be able to do this with the educational version of the software. So there's a commercial version, there's the educational version, and then there's the home learning edition. The home learning edition will not let you create the NC file. The education and commercial version will. So with the first operation selected, I got green checks next to everything. I'll select G1. I'm going to create the NC file and the NCI file. I'll select OK. Now, this is going to be a multi-operation part. There's going to be multiple NC files. So what we might want to do is name them with something that will be useful to us down the road. So I'm going to call this Softjaw Mill first operation. And then I'll name the NC, well, that was the NC file. So I'll name the NCI file and NC file the same way. So Softjaw Mill first operation. And once you save the NC file, it's going to open up Code Expert, and we'll see the NC file, which basically converts these graphical representations of toolpaths to a language that the machine will understand, G&M code. So we'll call this 8051, and I'll take note of this because what we're going to do for the next ones, we're going to call it 80. This is 8050. We'll make the second operation 8051. So from here, you can scroll through the code. This is the language that the machine understands and will basically be used to machine the first operation of the mill Softjaw. So from here, I'll exit out of the Code Expert. Oh, cancel that. If I go back to the project page, that completes the first operation. We now need to move on to the second operation. So the nice thing about the second operation, I'll point this out, most of the toolpaths already exist. We're just going to copy and paste and make a few changes to the pasted tool or to the copied toolpaths. So step 1, turn the part over, rotate view, not part, and create a new coordinate system on the other side of the part and name it second operation. So go back into Mastercam. Look at the part from the isometric view. And something that I didn't do, and I'm going to do it. I'm going to back up a little bit. Let's create the stock model that shows the first operation completed. So insertion arrow at the very end of the toolpath group. In the toolpaths tab, go to stock model. I'll call this one first operation complete. For the initial stock shape, let's use the stock model, the last stock model that we created. And we'll call this, well, that's the last one we created, is the 0.03 chamfers. And then for the source operation, select that chamfering the last chamfering operation that we created. Select OK. You zoom in, you can barely see the chamfers through the solid model. And what I'm going to do, I'm going to look at it from an isometric view. and I'll fit my screen. What we're going to do, so first off, let's visualize this part sitting in the vise. And we're holding on to this gray area. This is the excess material that we're holding on to from the first operation or for the first operation. What we're going to do now is we're going to flip the part over. This face that my cursor's on is going to go on top of the parallels or into the vise. It's going to go down. And we're going to clamp on this face and this face. And the material that needs to be removed will be facing up. So we basically got to flip the part over. This is what I want you to do. I want you to look at it from an isometric view. Zoom out a little bit. We're going to rotate this about the y-axis. We're going to pivot about the y-axis. Hold the Y key down. And then hold your scroll wheel down and move your mouse. And I'll do that a couple different times. So from an isometric view, on your keyboard, hold the Y key down. And then push your scroll wheel down with your mouse and move your mouse. And we're tumbling the part. Actually, we're tumbling the view. We're not moving the part. We're tumbling our view. So we're tumbling the view so that the material that needs to be machined is facing up. The old coordinate system is now upside down. It's at the upper left side of the new orientation. And this is what I want. I'll do it one more time. So from a default isometric view, hold the Y key down, press the scroll wheel down on your mouse and move the mouse. And the only thing is it's rotating the view about the Y-axis. And now the coordinate system should be what appears to be the upper left corner, and the Z-axis is pointing down. So we just basically flip the part over. You need to visualize unclamping the vise, flipping the part over 180 degrees, and then clamping it down again. We're going to need to create a new coordinate system. If I go back to the project page, let's see here. So turn part over. Yep. So we're still on step one. I no longer need to see, I guess I could keep it visible, the stock model. Let's create a new coordinate system and we'll call it the second operation. Go to the planes manager. To create a new plane, you're going to select the green plus sign, create a new plane. And from the drop-down menu, select from solid face. Mastercam is prompting us to select a flat solid face. Select the top face. So I'm selecting it right here. And you'll see that coordinate system appear. You could scroll through the different options. Z will always be perpendicular to the selected flat face. But the first operation is the one that's working for me. So what I'll do is I'll select OK. That brings up the parameters for the new plane that we just created. Call this one second operation. Don't worry about the origin. I'm going to move this to this corner. I want the coordinate system on machined surfaces or machined edges. So we're still in the parameters for the new plane. Select reselect. When you move your cursor to the graphics area, you'll see the coordinate system attached to your cursor. I'm going to let my cursor lock on to this edge or this endpoint right here. When I see it snap into position, left click. And then I'll select OK. So now you can see positive X is going to the right, positive Y is going forward, and positive Z is going up. That's the orientation or the direction of our axes on our CNC mill. From here, I'll save my work. And I'll go back to the project page. So now we're moving on to step 2. It says create a new toolpath group and name it second operation. I'll go back into Mastercam. Go back to the toolpath manager. Now, the toolpath manager is getting a little cluttered. We have a lot going on. So once we're done with the first operation toolpath group, we can minimize it. If we ever need to get access or get back to the existing toolpaths, we can just expand it. But for the time being, I'm going to minimize it. Now we're going to create a new or a second toolpath group. Be careful, because you can create toolpath groups within toolpath groups. That's not what we want to do right here. We want to left click on the machine group. Machine group is a selected item, the Haas VF2. Then right click from the file menu, select groups, new toolpath group. And then name it second operation. I've got the insertion arrow after the second operation. And we're ready to start creating or placing toolpaths under the second operation. If I go back to the project page, step 3, use a contour toolpath to remove the majority of the overhanging material left over from the first operation. So let's do this. We used a contour toolpath. We had a dedicated roughing toolpath where we use that 1-inch flat end mill. I'm going to remove this material, and I'm not too concerned about the surface finish, because everything that's in gray, everything that you're seeing above the part right here is all going away. We're machining all this way. I'm not concerned about the surface finish. So what I'm going to do is I'm going to copy a toolpath from the first operation toolpath group. Now we need to be careful when we do this. I'll expand the first operation toolpath group. The contour toolpath, where we have the 1-inch flat end mill. This is the one that we're copying. So select the contour 2D with the 1-inch flat end mill. I have a green check next to just that toolpath. Right click on it, copy. Be careful, do not cut. Right click, copy. Go down to the second operation toolpath group, right click, paste. And I'll minimize the first operation again. I'll end up going back to it, but for now I'm just minimizing it. I got this copied toolpath, and we're going to need to change several things. The first that I would like to change, if I expand it, what tool plane is this copied toolpath currently referencing? I'm giving you a hint. It's referencing the first operation. We need to change the construction plane. I'm sorry, we need to change the tool plane that this toolpath is referencing. Right now, the Z would be coming from underneath the part, the wrong direction. Go to parameters. Go to planes. I'll start with I'm going to change all of these where it says working coordinate system. Select this icon. Select WCS plane. And scroll up or scroll down, depending on which. Yeah, so mine at the bottom. Select the second operation. When you select it, you see it become visible over here. So select the second operation, select OK. And now I'd like to carry this over to the tool plane and to the construction plane. So I'll select this icon and this icon. From here, go up to toolpath type. We can access the chain geometry while we're inside of the parameters for the toolpath from the toolpath type page. So where it says chain geometry, if I select it, it brings up the chain manager. Now remember, this chain is from the first operation. So what I'll do is I'll right click in this field, rechain all. I'm tumbling my view. And I'm going to select this edge right here so that the chain's going in a clockwise direction. I'll select OK. The large arrow shows us the direction of the chain. The small arrow shows us which side of the chain the tool is going to be on. So I'll select OK. And let's see here. Let's go down to cut parameters. I'm leaving 20 thou on the wall. That's fine. All of this is getting machined away anyway. Depth cuts, don't need it. So we'll turn it off. Lead in, lead out. The 25% default should work just fine. Breakthrough. Breakthrough will probably be fine because we left 20 thou on the wall. Multi-passes, don't need it. Linking parameters, we need to change something here. And remember, these values are relative to the current coordinate system. And something's looking odd to me. Hold on. All right, it's all good. So linking parameters. Top of the stock. I'm going to select. It's not letting me select anything because we cannot select a stock model edge. So what we have to do is we have to go back to levels, make the material level visible, lock on to what's now considered the top of the part. Once we flipped it over, this is considered the top of the part. So select it. And then for the depth, I'm selecting the top of the part now. So I've got 1.48 for the top of the stock absolute, and then for the depth, I've got 1.25 absolute. That should take care of all the changes. Now remember, this is a copy toolpath, so a lot of the stuff has already been defined. From here, I'll select OK. I no longer need to see a stock model from the first operation. Really don't need to see the material level. I'll need to regenerate this toolpath. We made some changes to it. We now have a red X, we have a red X next to it, so I need to regenerate all dirty operations. Let's see what this toolpath looks like in backplot. I've got the toolpath selected. I'll select backplot. We're doing one pass at one depth of cut. If I select play, this is what we're getting. It's just knocking off that overhanging material. That way, when we come by with a face mill, when we machine away the face mill, nothing has a tendency to overlap or get hung up and then tear away as the face mill is cutting through it. This overhang wasn't that much, so it might not be a problem, but I'm just going to err on the side of safety with this. So I machined away the extra material that was overlapping the finished walls. I'll toggle off the visibility of the new toolpath. Before I run verify, I need to update my stock setup. Go to stock setup. Stock plane should still be set at the top. This time, instead of a solid, remember for the first operation, we had that solid that we created, our material representation. So the majority of that has been machined away now. So what I want to represent the stock for the second operation is that STL file that we created that reflects all of the machined operations from the first operation. So let's go to File. Select this icon here. Now we're going to navigate to wherever you saved that machined STL file. I'm going to go to my C drive, and I'm looking in this master's folder. I've got a project folder called Softjaw Mill. And then I have the first operation complete STL file. I'll select OK. To get an idea of what it looks like, what it's going to look like inside of Verify, I'll select Display, and I have Solid selected. From here, I'll select OK. And it looks a lot like our stock model from the first operation. So that's what my stock's going to look like inside of Verify. Once I verify that it's correct, I'll toggle off the display. I'll save my work. And now I'm going to run just the second operation in Verify. You'll notice that none of the toolpaths from the first operation are selected. I'm just verifying the second operation. So I'll select Verify. You can now see there is what the part's going to look like in the vise before we do any machining for the second operation. Make sure stop condition collision is turned on and then run it. All we did is knock off that overhanging material. You can see that the tool did not come into contact with the machine, with the finished surface or this machine surface from the previous operation. If it was undercutting, we'd have to make some changes, but everything looks good. So from here, I'll exit Verify. I'll save my work. We'll need to create the stock model that reflects everything up to this point. So once again, insertion arrows at the very end of your toolpath group. Toolpath tab. In the stock section, select stock model. For the source operation, I'm sorry, not source operation, for the name, let's call this second operation contour. For the initial stock shape, we're going to use the first operation complete stock model. And then for the source operation, let's select the contour toolpath that we just created. Select OK. So this is what the part's going to look like in the machine once this contour toolpath is finished. We're now going to come in with a face mill and machine away the excess material down to the top face of the part. So once you verify that the stock model is correct, you can toggle off the visibility of it. I'll go to the level manager, make the material level visible. Go back to the project page. And we've moved on to step 4. Use a face toolpath to machine the part to the finished thickness. Okay. I've already got a facing operation. So once again, we can copy and paste an existing toolpath. So I'm back in the toolpath manager. Minimize this, minimize this. The insertion arrow is at the very end of the second operation. I need to borrow something or copy something from the first operation. So I'll expand it. This facing op. Make sure that that is the only item selected. There's a green check next to just the facing operation. With just that operation selected, right click on it, copy. And minimize the first operation next to the insertion arrow. The very end of the second operation, right click and paste. If you need to expand the new facing operation, the first thing that I would like to change will be the tool plane. Expand the parameters. Select planes. You can see that this toolpath is referencing the first operation. So I'll select WCS plane, this icon. Change over to the second operation, and then carry it over to the tool plane and carry it over to the construction plane. I'm also going to reselect the chain that's driving this facing operation. So I'll go to the toolpath type. I'll select chain geometry. Now the chain that's currently driving this toolpath is on the bottom. I'm just going to change it so it's on the top. Right click, rechain all. Change over to a solid chaining method. I've got C plane selected. Selection method is set to loop and to face. Select the top of the material. Chain's going in a clockwise direction. That should be fine. From here, I'll select OK. Chain's going in a clockwise direction. You can see that the small arrow is pointing outboard. That's what I want. So from here, I'll select OK. For the tool, now remember, this is a copy toolpath. Things that we'll need to change. Go to cut parameters. All of this is good. Depth cuts. Now on the first operation, first facing operation, we only took off 20 thousandths off the top of the part. We need to take a lot of material off. So if we do this in one pass, we're going to have the tool's gonna be working too hard. So let's activate depth cuts and set the max rough step 50 thou. And then set the number of finished cuts to 1 and set the finished step to 0.02. From here, go to linking parameters. Clearance should be good. Let's set the retract to 1.5 absolute. Feed plane is 0.1 incremental. That should be fine. Top of stock, I have it set to absolute. I'll select the top of stock icon. I'll let my cursor lock onto the top of the part. For the depth, I have it set to absolute. I'll select the depth icon. And now I'm going to zoom in and I'm going to lock on to the top of the part. So my bad, I might have said top of part for the top of the stock. So top of stock, locking onto the top of the material. And then for the depth, I'm locking onto the top of the part. From here, I'll select OK. I'll need to regenerate this toolpath. And it says one more selected operation is dirty and may require, yeah, I selected the wrong, I selected the back plot. So select regenerate all dirty operations. And now it just said toolpath selected. I'll run it in back plot. I don't like how it's repositioning itself. So let me check on something. If I go back here, parameters. Let's see here. Retract. I'm going to change this to 2. Cut parameters should be 1 pass. I'll regenerate that and I'll run it back plot again. That's better. From here, I'll save my work. I'll select the entire second operation toolpath group and I'll run it and verify. Make sure stop condition collision is turned on, and then I'll select play. Once it's done running and verify, I'll zoom in, I'll inspect the model. Now, everything, all the machined edges, machine faces should line up with the wireframe representation of the part. So for the most part, this part is complete. But what I'd like to do is I'd like to use a chamfer mill to knock any sharp edges off created from the second operation. So that's what we'll do next. So from here, I'll exit out of verify. I no longer need to see my material level. So I'll go to level manager. I'll turn the material level off. I'm looking at it from an isometric view. I'm fitting my screen. I'll zoom out a little bit and then I'll save my work again. Now ready to create the next toolpath. So now that I've completed the facing operation for the second operation, all I need to do is really take off the sharp edges created from all of the machining operations for the second operation. But before I do that, let's create the stock model that reflects everything that we've done up to this point. So insertion arrow at the very end of the toolpath group, second operation toolpath group. Go to the toolpath tab, stock section, stock model. We'll call this second operation facing. And for the initial stock shape, let's use the stock model from the previous op. So the second operation contour. And for the source operation, select the facing operation that we just copied or just created. From here, I'll select OK. You can barely see the stock model, pretty much matches the solid model that represents our part. Once you verify that it's correct, toggle off the visibility of it. I'm going to reference the project page. Step 5. Use a contour 2D chamfer toolpath to break all sharp edges created by the second operation. We've already got a toolpath that did that for the first operation. So once again, we're going to copy and paste. I'll expand the first operation. Now, be careful. We got 2 contour toolpaths and they got different, we have 2 chamfering operations. They have different chamfer sizes. I'm going to copy the one that has the smaller chamfer. I just saw this right here. I didn't update the note for this contour right here. So I'm going to do that real quick. So this is the second chamfer operation. We're creating the smaller chamfer. So go into the parameters under tool. And instead of saying quarter-inch chamfer machine, 0.01 chamfer, or something like that, I'm going to say break all sharp edges. All caps. That's the toolpath that I'm going to copy. So I'll select that chamfering operation, right click copy. I'll minimize the first operation toolpath group. Now my insertion arrow disappeared. So I'll just hit the down arrow until it reappears. Place it at the very end of the second operation toolpath group, right click paste. Anytime I copy a toolpath, the first thing that I want to change is I want to make sure that the tool plane is correct. So I'll go into the parameters of that copied toolpath. I'll go to planes. Let's start by changing the WCS to the second operation. So I'll select WCS plane, second operation, and then I'll carry it over to the tool plane, and I'll carry it over to the construction plane. Go up to the very top where it says toolpath type. For the chain geometry, I'll select chains. You can see that the current chains, the chains that populate this field, are for the previous operation. So I'll right click in this field, rechain all. Brings up the solid chaining dialog box. I'm going to change over to the wireframe chaining. So I'll select this icon. C plane is selected. Selection method is chain. I'll select the outer edge of the part here. And then I'll select this circle at around the 7 o'clock. Go in the wrong direction so I can flip it. And then I'll select this one at around the 3 o'clock or 2 o'clock, I should say. Once you have those 3 chains selected, select OK. Brings up the chain manager again. Here's where you can double check, make sure that the chains are going in the right direction, the tool's on the right side. So everything here looks to be correct. I'll select OK. I don't think I need to change anything. The note, a 1/2-inch chamfer, break all sharp edges, second operation. Something that we might want to check on is the linking parameters. And relative to our current coordinate system, these should work just fine. From here, I'll select OK. I'll need to regenerate this toolpath group, or I'm sorry, regenerate this toolpath. Once I regenerate it, let's run it in backplot. Machines the outer edge of the part, then it goes into the drilled holes and breaks any sharp edge that might have been created. Everything appears to be good, so I'll exit backplot. I'll save my work. I'm going to select the entire second operation toolpath group, and we're going to run this and verify. Hoping I saved my work prior to going into verify. Once inside of verify, make sure stop condition collision is turned on. And then select the play button. You zoom in, I'm inspecting the machined model. You can see that I've got chamfers on the sharp edges. The profile of the part pretty much matches the wireframe representation of the part, so I'm liking what I'm seeing. I'm now going to save this machine model as an STL file, and I'll call this Softjaw Mill complete. So inside of verify, from the verify tab, save stock as STL. I'll call this Softjaw Mill complete, or finished part, something like that, something that makes sense. I think I like finished part better. Takes a moment to save it. Still saving it. All right, so now it's done saving it. I'll exit verified. And if we go back to the project page, it says use contour 2D chamfer. Okay, we did that. It says create the NC file using the post selected operations. So before we create the NC file, I'm going to do this, but I'm not going to go through with it. I just want to show you a few things that we need to be aware of. So if I just select this and select G1, select OK. It says, okay, not all have been, we're not selecting all for posting. That's fine. Post all, no. Now we need to be careful. It wants to save it as Softjaw Mill first operation. So we definitely want to change it to second operation. But before I even do that, what's going to happen, and I'll just tell you right now, what's going to happen is it's going to save it as program number 7050. And where we can see that, I expand all this, not seeing it. Let me do this. Go to display options. And let's see, operation comments. Okay. So what I'd like to do is I'd like to rename these program numbers. So first operation, that's going to be let me see here. If I go right click and I go to edit selected operation, change program number. See how it's set to 8050? I want to leave that one alone. But when I come down here, I want to select these, right click, edit selected operation, to change the program number to something different. So change program number. This will be 8051. And something else. So let me just post this out real quick. So with just these toolpaths selected, I'll select G1, select OK. I don't want to post everything because I don't want these part of this program. So I'll select no. I'll call this one Softjaw Mill second operation. This will also be Softjaw Mill second operation. Here we have 8051. It doesn't conflict with the previous NC file that we created. What's happening is it's creating this work offset G54. Now we haven't talked that much about these because you become more familiar with these when you take the 150 class. These are work offsets, and sometimes we want to assign different work offsets to different parts, different operations. For me to change this, I want this to be G55. Inside of this particular machine definition, if I go back in the Mastercam, go to planes, here, where it says the first operation, I'll select manual, set this to 0, let it update. And then I'll select the second operation, manual, and change this to 1. Now, when I create the first operation, the default was G54. So right now we're telling it to be G54 no matter what. The second operation, this is going to become, when I create the NC file, it's going to create all or associate all tool paths with work offset G55. And I'll show you what's going to happen when we create the NC file. So this is G54, and you'll see it being referenced at every tool chain or at the beginning of every tool path. Now, because we changed that to manual 1, when I create this NC file, I'll repost it. So with the second operation selected, G1, I'll select OK. And overwrite the existing NCI file. Overwrite the existing NC file. Now, back to code experts can ask us if we want to reload the changes. Watch what happens to this G54. It's now G55, and that'll turn up at every tool change. So what that allows us to do, allows us to have multiple vice or multiple fixtures on the vice or on the machine. Example, if I go back to the home page here, and let's just talk about an image that we see on the home page. Here's a vise with a workpiece in it. So I want you guys to visualize 2 vice on our machine. The one vice will be holding on to the raw material for the first operation. And then the second vice, we'll say it's to the right of this vice, is going to hold on to the first operation complete, the parts flipped upside down. So this one would be G54, and then the vice next to it would be G55. So this is just a way that we can set the machines up where we can run, the first and the second operation at the same time. different ways to do it. I just wanted to show you guys how to, I'm just introducing different work offsets for different toolpath groups. And that's what we see here when inside of the NC file. So all of these toolpaths would go to the vise on the right. All the toolpaths from the other program, which are referencing G54, would go to the vise on the left. That's just a simple way to look at it. So anyway, I'm done creating this NC file. I'll close out of it. I'll save my file one last time. I didn't create the stock model. We'll create one more stock model. I'll go to toolpaths, stock model. For the name, we'll call this finished part. For the initial stock shape, let's use the previous, we'll use second operation facing. And then for the source operation, we'll select that last contour toolpath. Select OK. If I go back to the level manager, make the solid model level invisible, we're now looking at what the part or what the finished part would look like once it's done being machined. This one has the initials in it. It also has the chamfers or the corner breaks all on around all the sharp edges. So good representation of what would be coming off the machine. So I'll make the solid model level visible again. I'll toggle off the visibility of the stock model. I'm looking at it from an isometric view. And I'll save my work one last time. Now that pretty much completes the Softjaw Mill project. If I go back to the project page, let's go to modules. And then if I go to Softjaw Mill discussion, go all the way down to the end of the instructions. We've done all of the required work, all of the instructions, all the things that we're instructed to do, we have completed. I now need to upload all the required files to Canvas. Now, if I go to the file manager and look in my working folder, let's just take notice or take note of what we've done and what might still need to be done. So file 160. I've created 2 STL files. I've got 2 NC files, 2 NCI files, and I've got my Mastercam file. I believe the last thing we need to create is the setup sheet. If I go back into Mastercam, I'm going to look at it from the isometric view for the first operation. So first operation, I'm in the plane manager. I make the first operation the active construction plane. I look at it from an isometric view. This is the view that's going to appear in our setup sheet. So I like to set it to my default isometric view. In this case, for the first operation. To create the setup sheet, I'm going into the toolpath manager. In an open area, I'll right click. I'll select setup sheet. And actually what I need to do is I need to select, let's do this. This would be a better idea. I'm selecting the machine group, the Haas VF2. Now right click, setup sheet. There we go. We'll call this Softjaw Mill. Once again, customer San Diego City College, programmer, put your name here, accept the defaults. I'll select OK. Takes a moment to create the setup sheet. Once it's done, it's going to open up in the reports viewer. And then we'll save that file as a PDF so we can upload it to Canvas. So it's opening up the active reports viewer. And I'm just kind of scrolling through. That's stocks from the second operation. Don't worry about it. Just keep it the way it is. All right, so looks like everything's there. So once it opens up, you're going to go to File, Save As. You're going to save it as a PDF, portable document format. Make sure you're saving it in the correct folder. So MACT 160 Fall. We'll call this Softjaw Mill. We'll call it Setup Sheet. Once you save it, go back to the project folder. You can see this, the PDF is now saved to this location. I'll exit out of the, yep, saved. I'm exiting out of the active reports viewer. So what I'm going to do now is I'm going to zip this file up. I'm going to compress it. Now, the way my computer works, if I right click on the folder, so Softjaw Mill folder, everything that I need is in here. If I right click on it and I go to 7-zip, the option that I will use will be, let's see here, add to Softjaw Mill 7-zip. Actually, I'm using this one right here, add to Softjaw Mill 7-zip, or just a zip. Here's a compressed folder. I'll now upload this to Canvas. I'm inside of Canvas. I need to look at it from student view. So you guys are seeing, or I'm seeing what you guys are seeing. So if I go to student view, this is the idea behind this, is that it resembles what you're seeing. I can see what you see. I'm going to go to modules. Module 3, Softjaw Mill. Here is the Softjaw Mill assignment. This is where we need to upload the zipped up file to. So I'll select Softjaw Mill assignment. Here's a grading rubric. So before you upload it, just work your way through this and make sure that you've done everything that this grading rubric is specifying that you need to do. And if you've done all of this, you're good. You can select Start Assignment. When you get to this page, I'll select Upload File, choose File, and I'm navigate to the working folder or the class folder. Inside my class folder, here is the Softjaw Mill compressed file or zip file. Open it up. Once you have it selected, you're going to select Submit Assignment. And here's some type of indicator that we are successful in uploading it. And it's submitted. Now you get 2 opportunities to upload this file. You upload it the first time. We'll take a look at it. If any changes need to be made, we'll let you know. There'll be some type of comment next to the different sections of the rubric. And if you don't get maximum points, read the comment next to that field. It'll give you some instruction on what you need to fix. Go back in and fix it. Once you fix everything, re-upload it, and then we'll regrade it, and you'll get the better grade. So from here, I'm going to leave student view, and actually I should go back to student view. Let me show you something. So once you upload it, go to grades. And here is a Softjaw Mill assignment. You can see that I've submitted it. It has yet to be graded. And if you're missing items, you'll see missing here. So if you're missing a quiz, or you're missing an assignment, missing anything, if you're missing anything, it'll turn up here. If you're missing something, upload the file. If you can't upload it, contact me and we'll work around that. We'll figure out how you can upload it. If you're missing a quiz, contact me. We'll make the test available to you. Anytime you're missing something from your grades, you can check this. And if you're missing something, you need to submit it or take the quiz or take, do the work. If for whatever reason Canvas doesn't let you upload something, or if the quiz is no longer available, contact me and we'll work around it. There's ways to pretty much fix everything inside of Canvas. So check your grades, check them frequently, and if there are ever any issues, please let me know. So from here, I'll leave the student view. And didn't mean to go there. I'm back on the project or the home page. If I go to the modules, and we just completed the assignment for module 3. You still need to submit the mill assignment. That's not due until October 28th. And then on that day, we'll also be taking the test associated with module 3. This is all going to take place after the midterm. If I go to the calendar, and here's the calendar for this class. Today is the 14th. And we're talking about, we're supposed to start matching parts cavity, modeling that one up. We'll probably do a little bit of work with that. I can get through the 2D representation of that part this tonight. But you can see a week from tonight, we've got the midterm hands-on. You will be required to come to San Diego City College, the T building, room T195. And you're going to use the computers there, the Mastercam that's on the computers there. And you're going to work your way through a project very similar to, the midterm is set up to resemble the projects that we've been working on. You're going to get a drawing, or let me rephrase that. You're going to be given instructions through Canvas, very similar to what you see on the project page. You're going to create a model of a part, and you're going to create several toolpaths. It's nothing that's going to be, it won't be anything that you haven't already seen. By working through the assignments that we've been giving you, or the assignments that I've been demonstrating to you guys, that's preparation for the midterm. So if you can do all the assignments that I've done up to this point, you'll be fine. All right. So the best way to prepare for the midterm would be to revisit the assignments that we've done as a group. So from here, that completes the module 3, the Softjaw Mill project. The next assignment, or the next module we're moving on to, will be called the matching parts core.